Now, let us start with our lesson. What is a rational function? Let me move to the next slides. Now, what is a rational function? A rational function is a function of the form f of x equals p of x over q of x, where the numerator and the denominator are both polynomials and the denominator is not equal to 0. Now, the main question will be, how will you know when p of x and q of x are both polynomials? Now, let me have the other question. When is it not a polynomial? It is not a polynomial when, first, you have a negative exponent. So, like x to the power of -3. That's not a polynomial function. Another, when your exponent is a fraction, that is not a polynomial function. Next one, when the variable is found inside the radical sign. If you have x squared of 4, yes, it's okay. But if you have 4 square root of x, the variable is the radicand, so it's not a polynomial function. So these are some of the situations wherein it's not a polynomial function. Now again, p of x and q of x are both polynomials. Ma'am, what if there's no denominator? Like you only have f of x equals 5x. It's still a rational function because the denominator of this is 1, and 1 is a polynomial with a constant term. Remember last time, it's a constant function. Now, let's talk about some examples on rational functions and what are some examples of not rational functions. Here are some. For example, 1 over x, rational function. X squared plus 3 over x minus 1, rational function. The next one, x squared plus 7x plus 10 all over x plus 2, rational function. And here are some non-examples of rational functions. The first one, the exponent is negative, so it's not a rational function. The second, the variable is in a radical sign. Therefore, it's not a rational function. The next one, the exponent is a fraction, so it's not a rational function. Again, in the rational function f of x, the numerator and the denominator, these are both polynomials. Let's go to the next one. How do we identify whether it's a rational function, a rational equation, and a rational inequality? We go back to our main description for the rational function. Remember, f of x is also called y. So you can have y instead of f of x. It's a rational function when the one side is an f of x or a y. The next one, when we use equations or equal sign, we call it a rational equation. Example, like this one. Or you can also have x squared plus 3 over x minus 1 equals 5x plus 10 over 3. Remember, even if there are so many rational terms, like this one and this and this and also this, but all are polynomials, and there's an equal sign. So we call it rational equation. If we have the same thing, but the sign is an inequality, like greater than, less than, greater than or equal to, or less than or equal to, we call it a rational inequality. So again, if it's a function, an f of x or a y, it's a rational function. If it has it's a rational expression, but with an equal sign, we call it a rational equation. If it's a rational expression with an inequality sign, then we call it a rational inequality. But if some of the terms are not polynomials or not polynomial expressions, then it's none of this, none of the three that you have mentioned. Now, here are some examples. Ready? The first one, prepare your chat boxes. Can you tell me what the first one is? Is it a rational function, rational equation, or rational inequality, or none of this? Ready? In your chat boxes, number one, 2 plus x over x minus 1 equals 8. Very good. It is a rational equation. I'll just write RE, okay? Next, number two. X is greater than the square root of x plus 2. You might be confused with the inequality, but look at the radical side. X is a radicand, so none of this. It's not a rational inequality. Next, number three. Ready? Number three. F of x equals 6 minus x plus 3 over x squared minus 5. Very good. It's a rational function. Here's your cue. Next, number four. 2x is greater than or equal to 7 over x plus 4. We check. All the terms are rational expressions. And there's an inequality sign. So rational inequality. Very good. And number five, the last number. X over 2 is equal to 4 over x plus 9x cubed. You check first. Is this a rational expression? Yes. Is this a rational expression? Yes. And with an equal sign? So it's a rational equation. Oh, very good. I think you're very ready for today's quiz. And let's have the last problem. Ready? Here's our sample problem for the day. An object is to travel a distance of 10 meters. Express velocity as a function v of t of distance per travel time in seconds. Okay, now we need to express velocity. That's v of t. What is it a function of? Distance, that's our d, per travel time. Let's have it as RT, okay? Now, remember that an object is to travel a distance of 10 meters. And our velocity is d over t. Now, there are two ways to do it. You can start with a table. Our distance is constant. It's 10. And here's our time. You see, if we travel for 1 second, then, wait first. That's only 10 for the distance. But if we travel for 2 Then let's have distance over time. That's 10 divided by 2. So our velocity of 10, our velocity will be 10 divided by 2. That's 5 meters per second. Next, if we travel for 3 seconds, our velocity will be 10 over 3. That's 3.3 something meters per second. So when we write velocity as a function of time, then our distance is constant. So we have 10 over t. This is how we write velocity as a function of distance per travel time in 10 seconds. If the given will be 20 meters, then it will also be in this form, 20 over t. Now, this ends today's lesson. Do you have any questions?